Okay, now the question A. Show that this sum is equal to this form for any, the ratio is from 0 to 1, and then evaluate the summation. So first, we know the left hand side is 1 plus the ratio plus ratio square plus 2 ratio to the n. If I have this times 1 minus r, if I multiply the left hand side by this, then we simplify it. Like 1 times 1 equals 1, and 1 minus times minus r is minus r. R times 1 is r, the ratio, minus r squared, and then plus r squared. Then finally we know this is 1 plus minus Rn plus 1. So since this equals 1 minus r to the n plus 1, so we know we divide by from the left hand side, so we can have the 1 plus r squared plus r to the n equals this divided by 1 minus ratio. So if I have a summation from k equals 0 to infinity, the ratio to the k, we will have 1 plus ratio square plus ratio to the n plus to the infinity. Then this means I have a limitation that n goes to infinity. When n goes to infinity and the ratio is between 0 to 1, then this equals 1 over 1 divided by 1 minus ratio for 0 to 1. So that's the part A. So part B. So part B. Part B is using the result of A and evaluate 1 plus 2 times ratio plus 3 times ratio square plus 4 times ratio cube to infinity. Since we know from part A, 1 plus ratio plus ratio square to the infinity equals 1 divided by 1 minus ratio, we can take the derivative on both sides. So if we take the derivative, f of 0, taking the derivative, on both sides. So we have 0 plus 1 plus 2 times ratio plus 3 times ratio square plus this will be 1 minus ratio square. Then that's the answer. So part C, using the result of part A and part B, then find the following sums. So first, I have a summation k equals 0 to infinity, and I have the k times the ratio k plus 1. So if we expand this first and see how it looks like, it is 1/3 square plus 2 times 1/3 cube plus 3 times the 1/3 of the ratio to the 4th and to the infinity. So here we can take the common terms outside, which is the ratio to the square, 1/3 to square. So it's 1 plus 2 times the ratio plus 3 times the ratio square. This one we know from part B. It's 1 minus ratio square in a denominator and 1 in the numerator. So which is 1/9 times 1 divided by 1 minus the ratio to the square. So this equals 1/4. So next one, summation k is from 2 to infinity, and it's k times, now the ratio is 1 divided by 4. It's 1/4. So we expand it first. It's 2 times the ratio plus 3 times the ratio to the square plus 4 times the ratio cube and to the infinity. Again, we take the common terms outside. Oh, there's no common terms, but we can do something. We add 1 and minus 1. So, and we still keep this term here. So it's 2 times the ratio, 3 times the ratio square. Why I add 1 and minus 1? Since this term is from part B. So I have 1 minus the ratio to the square minus 1. Then I got the answer is 7 divided by 9. Which is our final answer. So that is the exercise 1.